So we want to write the equation of the circle with the center at -1, -3, radius of 5. We're going to be using that equation that we wrote down yesterday. We actually came up with that equation using what? How did we come up with the equation? Let me write it down here. X minus h squared plus y minus k squared equals r squared. Where did that equation come from? Not the distance formula, but it came from the same source as the distance formula.
Pythagorean theorem.
Pythagorean theorem, exactly. So we showed that all of those points on the circle, for all of those points on the circle, we can draw a right triangle and have leg squared plus leg squared equals radius squared in this point, because the radius turned into the hypotenuse. So just filling in what we know into the equation, what's it going to look like? X plus what?
Y1 squared.
X plus 1 squared plus
Y plus 3 squared.
y plus 3 squared
Equals 25.
equals r squared, which is 25. Exactly. So that's the equation of the circle. So if we were to draw a circle that's centered at -1, -3, and has a radius of 5, this equation right here would describe all of those points on that circle. So we could put in a number for x, figure out what y is, and the point that we get out of that would be a point that's on the circle. And in fact, we could get any point that's on the circle that way. Okay, so the next thing I ask you to do is plot 12 points that you know must be on the circle. Like I said, there's 4 easy ones. I'm going to start by just plotting the center of the circle because we need to know where to start from. -1, -3 will go left 1 and down 3. So there's the center. Do you guys agree with that? Is that good? Mm-hmm. Okay, somebody tell me how we get the 4 easy ones. Raven?
You could go up 5.
Okay, so if we go up 5, we get that point, right?
You can go down 5.
If we go down 5, we'll get there.
And you can go to both sides 5.
Okay, so right 5, we get there. And left 5, we get there. Now, I don't know about you guys, but I'm not great at drawing circles. At this point, if you were going to try to draw a circle, I see a lot of students that do this. Looks like a pretty good circle, right? Nah. I'm not going to grade you on your artistic ability, but I do want you to try to make it look like a circle. And one thing we can do to help out with that is get some other points on there. We're not always going to be able to do this, but in this case we can, and we can do it because the radius is 5. Now that number is special because why? Anybody know? Where did this equation come from again? Pythagorean theorem, which means that we had triangles, right? Yeah. And the hypotenuse of that triangle was
5.
The radius.
Oh.
So we want a triangle with a hypotenuse of 5. What kind of triangle has a hypotenuse of 5?
3, 4.
A 3, 4, 5 triangle. So if I were to draw a 3, 4, 5 triangle in here with one corner at the center, say like this, so 3, 4, and 5, well, how does that help me with the circle? It gives me a point because this right here has a length of 5. I know that has a length of 5 because it's a 3, 4, 5 triangle. And my circle has a radius of 5. Let me get that back in there, but I'm going to draw a little lighter. My circle has a radius of 5, so that's exactly what I want it to be. So I know that I'm going to have a point right here that's on the circle. Does that make sense? We could do it again with a different 3, 4, 5 triangle. Let's say I go right 4 and up 3. Then that's going to give me a 3, 4, 5 triangle also. You guys agree with that? And it gives me another point here. Now, I said that there's 8 more, and that's just 2. So where are the other 6 going to be?
On the other side?
Yeah, up and to the left of the center, down and to the left of the center, and right into right and below the center. So we can go in any direction. We can go 4 and then 3. So we could go left 4 and up 3 and get that point. We could go left 3 and up 4 and get that point. And we could continue that all the way around the circle. Does it make sense how I'm getting these points?
Yeah.
For any one of them, I could draw in a right triangle where the hypotenuse is going to be 5 because they're all making 3, 4, 5 triangles. Now, I'm not going to get that squarish looking circle if I try to connect the dots here, am I? I think it's a little bit easier now with 12 points instead of 4 to get a decent looking circle. So I'll start at the top here and work my way around. And we get something close to that. Again, I'm not going to grade you on your artistic ability, but I do like you to try to be a little bit accurate when you can. And this particular circle, we can be a little bit more accurate. Okay, now for this next part, I said choose one of your 12 points. I'm actually going to eliminate 4 of those from your choices. I don't want you to pick any of those 4 that we started with, because that makes stuff a little bit trivial. So let's pick one of those other 8 points, and we're going to use the equation to analytically, algebraically, confirm that it is on the circle. Somebody pick one of those other 8 points for me. Just tell me the coordinates. Jake? 2, 1. All right, so the point 2, 1 we're going to use right here. Who thinks they know how we could confirm that that point is on that circle? No. Let's use the equation. We have the equation of the circle here. Yeah. We can put 2 in for x here. We can put 1 in for y here and see if we get a valid equation, get something that's true. If we do that, we're going to have 2 plus 1 squared plus 1 plus 3 squared, and hopefully that's going to equal 25. I'm going to put a question mark above our equal sign here because we don't really know right now. Actually, we do because it's a 3, 4, 5 triangle, but let's pretend like we don't know for sure that's on the circle yet. What is 2 plus 1? And 1 plus 3?
4.
Why do I hear a calculator coming out? What is 3 squared?
9.
4 squared? Is 9 plus 16 equal to 25?
Yeah.
Yes. Which means what?
That it's the points on
It means that the point's on the circle. Okay? So if we get something that's 25 equal to 25, anything is equal to itself, that point is on the circle. Just to show you that it doesn't always work, I mean, I could just be giving you an example where no matter what we put in there, it's going to work. Let's say we pick a point that we know is not on the circle, say 1, 1. Let's try that. If we put 1 and 1 in for x, let me use a different color here, then we're going to have 1 plus 1 squared plus 1 plus 3 squared equals 25. And what we end up with then is 4 plus 1 plus 3 is 4, right? So that's 16 equal 25. Are they equal? No. In fact, this is kind of cool because not only can we say it's not on the circle, but since 4 plus 16 is 20 and that's less than 25, we actually know that point is inside of the circle. If it was bigger than 25, then it would be outside of the circle. We're not going to get into that, but that is something we could do if we wanted to. Question, Raven?
So like, you know how we use the triangles to find other points? So
Mhm.
we only can use that if the radius is one of the perfect square hypotenuse.
Is one of the hypotenuses for a Pythagorean triple. Exactly. So Raven just asked a good question. We could only get those extra points here because the radius was 5, and we knew we have those 3, 4, 5 triangles. So if you have a hypotenuse in a Pythagorean triple that matches up with the radius, it'll work. If you have a number like 4, it's not going to work because 4 is not the hypotenuse in any kind of Pythagorean triple. So it doesn't really help you out. All right, so for the next few examples, next 4 examples, we're going to look at a picture of a circle, and we're going to write the equation of that circle. You've already got the picture in your notes. The lines didn't print exceptionally well, so you may have to refer to my picture up here a little bit. There's two things that we need to know to write the equation of a circle. What two things are they? It's actually written on your paper already. The center and the radius. So for each one of these, we'll start by figuring out what the center of the circle is and what the radius is. The center is easy. All we have to do is figure out the coordinates of point A there, which would be what? -3, -2. And the radius is not as easy, although this problem is pretty straightforward. What is the radius? In this case, I gave you a point on the circle. How could I find that radius? There's two ways. Jake?
Find the coordinate of the point and then subtract it from A as a center.
Okay. In this case, we can actually just subtract because the y-coordinates are the same, right? So since the y-coordinates are the same, we have that horizontal line segment. We can just do the -3 minus -7, and that's going to give us the length right there. So we can subtract, or this is the same thing as basically counting squares. So we have -3 minus -7, but this only works because it's a horizontal line segment. We're going to see a problem later, actually several problems later, where we're going to have to do something else to get this, to get the radius. In this case, though, it's pretty easy. What's the radius? 4. So then, writing the equation of that line, what's it going to look like? You guys agree with Kayla? Kayla, why are those +3 and +2 instead of -2 and -3?
Yeah, because the formula already says
X minus H and Y minus K. Yeah.
and so that was negative.
Good. So in the equation, we're subtracting those coordinates, and since we're subtracting a negative, since we have a -3 and a -2, that double negative is going to make it positive. So it's x plus 3 squared and y plus 2 squared. Any questions about that one? All right, next one. This one's a little bit trickier because the radius here is not going straight across. If we tried to do that, it would be 3 and a little bit. And a little bit is not easy to work with in math. We need to be a little bit more specific than that. All right, so first of all, we need the center point. What are the coordinates of the center here? Okay. Then we need the radius. So I'm going to draw in the radius here. And there are two ways that we could find the length of that radius. What are the two ways? What's that? Okay, we could draw a triangle, or we could use the distance formula. I actually like drawing the triangle here a little bit better. Or the distance formula would work equally well if we make an adjustment to it. But by drawing the triangle here, what's going to happen is we're going to get in our formula r squared. And we don't actually need to know what the radius is. What we actually need is the radius squared, don't we, for the equation? Because the equation doesn't have r in it, it has r squared. So this triangle here, when we set up the Pythagorean theorem, is going to have r squared in it, which is going to be kind of cool. It's going to allow us to skip a couple of steps. What is the length of this leg right here? 2? Why 2, Miles? Oh, it's not 2? No, it's actually going to be 1, right? So the length of this side right here, this leg, is going to be 1. It's just the distance between 4 and 5, right? And the length of this leg right here is going to be the distance between 4 and 1 on the y-axis, which is 3. 4 minus 1 is 3. And then to set up, what do we get when we set up an equation to solve for r?
What'd you say?
We need an equation to solve for r.
1 plus 3 equals r squared.
1 squared is? 3 squared is? 1 plus 9 is? And I'm going to go ahead and do this. I'm going to take the square root of both sides. So r is the square root of 10. However, we don't really need that because later on when we fill in our equation, we really want the r squared, right? All right. So what's the equation going to look like? Who wants it? Somebody be brave. Or just awake. I'll get you started. It starts with a parentheses. Okay, now you go. Miles, go ahead.
X minus 4 squared plus y minus 1 equals
Squared, right?
squared.
Equals r squared, which is,
Squared to 10.
no,
Oh,
10. Yeah. So we have x minus h squared. H is the x-coordinate of the center. So that's going to be x minus 4 squared. Plus y minus 1 squared equals r squared. And again, we didn't have to solve for r because we know r squared is 10, the step before that. So by setting up the Pythagorean theorem, we can save ourselves that step. Now, if you wanted to do the same thing with the distance formula, let me just show you this real quick. Let's say you want to use a distance formula. The distance formula is, and actually I'm going to use an r here for the distance because the distance we're looking for is the radius. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. And it's the square root of all that, right? Well, since we want r squared, what we can do is square both sides of this equation. Instead of having the square root, put the r squared there. And so we have the distance formula, but we can modify it a little bit to save ourselves a step in this problem. So if we plugged in all this stuff, if we plugged in 5 and 4 for x1 and y1, and 4 and 1 for x2 and y2, we would end up with 10 again for r squared. Does that make sense? We awake?
Yeah.
Okay, another one. Now, I'm going to give you a warning here. It looks to me like this point right here is on the circle. That point, negative 16, 0. It might be, it might not be, I'm not really sure. I don't want to risk it. I don't want to assume that it is on the circle and it turns out that it's really negative 16 and a little bit, or just a little bit less than negative 16. So let's use the 2 points that were given to us because we know what those are. Do you guys want to use the distance formula or the triangle? Distance formula? Alright, so we'll use the distance formula on this one. And remember, the distance formula here, we're going to modify it a little bit. We're going to leave the r squared in there instead of solving for the radius. So I want to find the length of this segment right here. Right there. And I'm going to do that by drawing, actually I'm not going to draw, I need the coordinates. What are the coordinates of the center here? Nope. Nope. Negative 3, 0. So the scale on here is 2, and that's halfway between the negative 2 and the negative 4, so that's actually going to be at negative 3, 0. And how about B? To negative 12. Alright, so the distance formula, remember we're going to modify it. So we're not going to have the square root on the right side. We're going to leave it as r squared on the left side. Everybody understand why I'm doing that? Yeah. Okay. So we're going to have x2 minus x1 in the first parentheses. What are we going to call x2? 2 or negative 3?
2.
2. Okay, so we're going to have 2 minus negative 3, right? Plus negative 12. You guys finish? Minus 0 squared. So it means that r squared is equal to, what is 2 minus negative 3? Okay, so we're going to have 5 squared there plus negative 12 squared there. What is 5 squared? 12 squared. So the radius squared is going to be 169, right? That's not the radius, but that's radius squared. What does that mean the radius would be? 13. Square root of 169 is 13. Okay, so I did put on there that we want the radius. Dante, you doing okay? Having trouble keeping up? We need a weekend, don't we?
Yeah.
So I did put a spot on your paper for the radius, so if you want to put the radius down, that's going to be 13. But the radius squared is going to be 169. All right, so what's that going to do for the equation? What's that going to look like? Come on, guys, you can do this.
Oh
X
my
plus
god.
3 squared plus y minus 0 squared equals 13.
Hold on, what's y minus 0?
Y squared equals 13. Oh, 169.
R squared, right? So it's going to be 169. Cool? Questions? Comments? Circles are fun?
Could be better.
All right, one more. Anybody recognize this circle? The circle has a special name.
What?
Semicircle.
A semicircle is a half of a circle. It is not a half of a circle. This particular full circle has a special name.
A full moon?
One.
Unit.
Unit circle.
Way to read.
Unite circle.
What does uni mean?
Unit.
1. So this means 1. What's 1 in this circle?
The circle.
The radius, right? The unit circle is, I need to do that again. The unit circle is a circle that has a radius of 1 and is centered at the origin. So the center of that circle is 0, 0. The radius of the circle is 1. So what's the equation going to look like? This one's the simplest one that you can get for a circle. X squared, because it's x minus 0, right? Plus y squared equals the radius squared. We saw that one yesterday, didn't we? You remember that? So that circle is called the unit circle. You'll actually see the unit circle occasionally from here on out. You see it a lot in trigonometry, analytic trigonometry. We just did right triangle trigonometry, but you'll see it some more. Okay, the next few examples, I'm going to give you an equation, and you want to take that equation and draw a picture of the circle. Now, we needed 2 pieces of information to get the equation of the circle. So if we are given the equation of the circle, that means we know 2 pieces of information from that. What 2 things do we know about this circle from this equation? The center and the radius. So for each one of these, we're going to write down the center and the radius first. The center of this circle is going to be 4, negative 2. Good. And the radius is going to be the square root of 4, which is 2. Why is it 2? Why isn't it 4?
It's r squared, so you have to.
Yeah, 4 is r squared, is the radius squared, so the square root of that is going to give us the radius. Okay, now with that information, we can go over to the graph and graph it. And we're going to graph it as accurately as we can. Sometimes we can be a little bit more accurate than others. In the opener, we were able to get 12 points. Let's see what we can get here. What should I do first? Plot the center. So 4, negative 2. We're going to go right 4 and down 2. We can't graph the radius because we don't know where to start, right, Maya? Okay, now from there, what should I do? Go up 2. Go down 2. left 2, and right 2.
This is small.
Now, if I connect the dots right now, I get something that looks like this, right?
A square.
So it's a good looking circle, isn't it? Are there any other points that we know are going to be on this circle?
No.
No, because the hypotenuse of this right triangle would be 2. The only right triangle that I know of that has a hypotenuse of 2, or at least one that we've talked about before, is the 30, 60, 90 triangle. You guys remember that?
Yep.
The problem is, one of the legs is 1, the other leg is the square root of 3. Does anybody know where the square root of 3 is on this graph? No, me neither. So that's not going to help us out here. One thing you want to be careful about now at this point, you want to try to make it look like a circle as much as you can. This point right here is the highest point on the circle. This is the lowest point on the circle. This is the farthest to the right, and this is the farthest to the left. So you don't want to draw something that looks like this. Okay, now I know that looks pretty bad, but this right here is a problem because it shouldn't go to the right of that point. That's going to be the farthest to the right it gets. So try to draw it as accurately as you can with what you're given.
Yeah, right.
Looks pretty good, right? All right, next example. Again, the two things that we want to get from the equation are going to be the center and the radius. Gesundheit. What's the center of this circle going to be? 0, 0. It's going to be the origin. What's the radius of this circle going to be? 15. The square root of 225. All right, so again, we'll go to the graph. You guys may notice on the graph that every fifth line is a little bit darker than the others. That was to help you out with problems like this. So the center is going to be at 0, 0. And then we want to go up 15. So that would be the third dark line. We want to go down 15. Right 15. And left 15. Use those dark lines and just count those. 5, 10, 15. Now, are there any Pythagorean triples that have a hypotenuse of 15? The 8, 15, 17? That's not going to do it. Because it's not the hypotenuse.
Oh,
I can think of one, though. What'd you say? What'd you say? Okay, but that's not 15. Okay. Oh, I didn't hear what you said. What'd you say, Allie? A 3, 4, 5 triangle. So if I put 3, 4, and 5 in this triangle here, I need the hypotenuse to be 15, so what do? Multiply everything by 3. So a 9, 12, 15 triangle is going to be able to help us out here. So just drawing a couple of them in here. Again, each of those dark lines is 5. So I can go right 9 and up 12. And that's going to get me to a point that's going to be on the circle, right here. Or, instead of going right 9 and up 12, I could go right 12 and up 9. That's going to get me to another point on the circle. And I can do that in every one of the quadrants, not just the first quadrant. And so I can go right 9 and down 12, right 12 and down 9, left 12 and down 9, left 9 and down 12, and so on. Sounds like fun, doesn't it? Dante, you're not doing this.
no, actually, I'm right.
So starting at any one of these points here, again, make it as accurate as you can. Oh no, I missed a little bit there. See if I can. There we go. How many of you have a good-looking circle?
What's circle?
Good looking circle.
I think that's pretty good.
I think we should have a circle drawing contest in here.
Alright, are you one of those things?
Nope. All right. Any questions about this one? Next one. This actually is our last example, but it's a multi-part example. It's a multi-part example because what's the problem? What's the difference between this one and the last two examples?
More letters in it and numbers?
Yeah, this equation here is not in the standard form equation for a circle. So the standard form is the one that we had x minus h squared plus y minus k squared equals r squared. Well, in this case, we have multiple x's, we have multiple y's, and it's all messed up. So before we even get to this example, we'll come back to it, but before we even get to it, we have to talk about something called completing the square. I mentioned this yesterday. Here are the steps that you're going to take to complete the square. Write those down, and I will talk about what some of those terms mean in a minute. So there's two things on here that need a little bit of explanation. First of all, we're going to be dealing with equations that are quadratic equations. So what's a quadratic equation?
Quad being scored on.
No, not in this case. That's the quadratic formula. So a quadratic equation is an equation such as x squared plus 6x minus 7. It's a quadratic equation because it has a square in it. Okay? This term right here, the squared term, is called the quadratic term. This negative 7 here, the number that's by itself, is called the, anybody know? C. Constant term. This term right here is called the
Second constant.
No, it's not. It's called the.
What does it start with?
Don't say it.
Linear.
linear term. That's called the linear term. This is called the linear term right here because if you were going to graph it, it would make a line. Okay? So if you graph the function or the equation y equals 6x, it would make a straight line. So that's the linear term because it makes a line. Step 1 should probably say not the linear term, but the coefficient of the linear term. So I need to clarify this. I mistyped that. I don't want to divide 6x by 2, but I want to divide 6 by 2. I want to divide that coefficient of the linear term. All right. The other thing I need to clarify here is what LHS stands for. Anybody have any idea? I actually used that a couple of times first semester when we were doing our algebraic proofs. An equation has a left-hand side and a right-hand side. LHS stands for left-hand side. Okay, so it's just the left side of the equation. This is assuming, of course, that the quadratic term is on the left side of the equation. If the quadratic term was on the right side, then we would do it on the right side. All right, so let's complete the square here in this example, and we want to rewrite this equation then with a perfect square on the left-hand side of the equation. On the right-hand side, we'll have whatever's left. Now, do you guys recognize these numbers from anything? The x squared and the minus 4x? Yeah, that's from example 47.14, but it's just the x part of it, right? So we're going to look at what's going to happen with just the x part here. What does step 1 say to do? Okay, so we're going to divide the coefficient of the linear term by 2. So in this case, we're going to take negative 4 and divide it by 2, and we get what? Negative 2, okay. Step 2 says to square that. What is negative 2 squared? 4. All right, so the next thing we're going to do now is we're going to, step 3 says, add the result to both sides of the equation. So we're going to add 4 to both sides of the equation. When I add 4 to the left side of the equation, can the 4 combine with either the x squared or the negative 4x? No, because they're not like terms, right? So when I add 4, I'm just going to tag it onto the end. So I end up with x squared minus 4x plus 4. I added it to the left side there. Now, what's 0 plus 4 on the right side? 4. All right, so that was step 3, right? Step 4 says to do what? We're going to factor the left-hand side of the equation. When we factor a quadratic, we're looking for numbers that multiply to get 4. So multiply to get 4 and add to get negative 4. What two numbers multiply to get 4 and add to get negative 4? Negative 2 and negative 2 and negative 2. Thanks, Don. All right, now, here's the thing about completing the square. That work is already done for you. First of all, if we do it right, it should be the same number. And it's going to be the same number because this 4 here came from squaring this negative 2, right? So by doing the step 1 and step 2, we get numbers here, negative 2 and negative 2. They're going to add up to negative 4 and that are going to multiply to get 4. Does that make sense? Yeah. So this step 1 right here, this negative 2 that we got, that's going to tell me what I'm going to get when I factor it. So I'm going to have x minus 2 times, didn't we say it was negative 2 and negative 2? Yeah. So x minus 2 times x minus 2 equals 4. Now, in step 4, I had you write down in parentheses what? Should be a perfect square. A perfect square is something that's to the second power, right? Is this a perfect square? Yeah. It is. It's not the way it's written, it doesn't look like it, but how could I write this so it is a perfect square? X minus 2 squared equals 4. Okay, now, notice I said we want the left-hand side of the equation to be a perfect square. The right-hand side just has whatever's left. So when we're doing this, when we're completing the square, we can use the right-hand side to keep things balanced. I couldn't just add 4 here without balancing it out on the other side and adding 4 over here. So that right-hand side allows me to add or subtract or whatever I need to do. And in fact, when we're completing the square, it's always going to be adding. But it allows me to add here and keep the equation valid. Okay? This right here is the equation that I wanted. Now, before we go on to the next part, why is that equation useful? Why is that more useful than this right here, the x squared minus 4x? What does this look like? It's part of the equation for a circle. Remember, the equation for a circle is x minus h squared plus y minus k squared equals r squared. Well, that is, lost it, that is the x part of the circle equation, right? So by completing the square, we're able to make it look more like the circle equation. Let's do the same thing with that one. Again, first step, we want to, what? Ooh. What do we want to do in the first step, guys? Okay, we're going to take the linear term and the coefficient specifically on the linear term and divide it by 2 and get what? 3. Second step, we're going to take that result and do what with it? Square it. And we get 9. So we're going to take that 9 and we're going to add it to both sides of the equation. So we have y squared plus 6y plus 9 equals 9. All right, step 3, actually that was step 3. Step 4, we want to factor it. Now I'm going to do this step one more time, but this is a step that we're going to start skipping. What two numbers multiply to get 9 and add to get 6? Positive 3 and positive 3. That comes from this right here, right? So we know that's going to be 3 and 3 because that first step is always going to tell me what it's going to be. So we're going to have y plus 3 and y plus 3. Now, why is this a step that we'll be able to start skipping? Because you can do what, Austin?
Y plus 3 squared.
Yeah, y plus 3 times y plus 3 is y plus 3 squared. So we know that we're going to get a perfect square here when we do this. So we'll just write it, skip that step, and write it as y plus 3 squared equals 9. Again, this is the equation I'm looking for, and this helps because it's the y part of the circle equation. Yes?
So, alright, for step number 1, it's all, well, for step number 4 is,
The first thing we want to do with this equation is we want to rewrite it so that the x's are together and the y's are together. Okay, since we have x's and y's here, we're going to complete the square twice. We're going to do it once for the x's and once for the y's. The AP. So I'm going to rewrite this as x squared minus 4x. So I'm going to put the x terms together. And then I'm going to leave a little bit of space here. Anybody know why I'm going to leave space there? That's going to be the square. So remember, step 3 in completing the square is to add or subtract, actually add that squared term to both sides. That's going to leave me space to add that in there. And then I'm going to do the same thing for the y's. So plus y squared plus 6y. And then leave a little bit of a space. And then I want to get rid of the plus 4 there. I want everything else to be on the other side. So what can I do with that 4 to get it on the other side? Yeah, I'm going to subtract 4 from both sides, and I end up with negative 4 there. All right, so that setup right there is going to allow me to complete the square on this particular equation. I'm going to make it a little bit smaller here. Okay, now, we already did this for these exact same numbers, but I want to do it again here. Looking at the x's, the linear term on the x is negative 4, right? Half of negative 4 is negative 2, and negative 2 squared is? So we're going to add 4 there. We can't just add 4, though. We have to add 4 on the left side and on the right side. So we're adding 4 to both sides. Now the same thing with the y's. What's half of 6?
3.
And square it? So we're going to add 9 to both sides. And when we do that now, what are we going to get here when we factor this? It's going to be minus 2, so it's going to be x. What? Help me out. X minus 2 squared. What are we going to get here with the y's? Plus 3 would be y plus 3 squared. And then with all this stuff here, we have a negative 4 plus 9. The negative 4 and the plus 4 cancel each other out, so we have the plus 9. So that's just equal to 9. This right here is the equation of the circle, but we still need to know what the center and the radius are, right? So we still need to graph it. So the center is going to be where? 2, negative 3. The radius is, what's the square root of 9? 3. So now we'll go over to the graph. Radius of 3, we're not going to have any triangles that are going to help us out. So it's kind of hard to tell here, but this is the origin right here in my graph. It's easier to see on yours. So 2, negative 3 will go right here. That's the center. And then what should I do from there? Up 3,
go down 3,
up 3, down 3, right 3, and left 3. And then there aren't any other points we can get, so just draw the circle as well as you can using those points. That is an ugly looking circle, but it's going to have to do. Questions?
no, y.
All these problems